All right, let's jump right in. Today, we're going to talk about a really powerful idea, how thinking like an architect can completely change the way you write code, how it can take you from just being a builder to being a true designer of software that's built to last. Okay, I know what you're thinking. That's a weird question, right? But what if I told you the answer is, well, pretty much everything? Seriously. The principles that keep a skyscraper standing tall through storms, the ones that let it adapt to new people and new uses for decades, those are the exact same principles that separate disposable code from truly great software. So let's start with the foundation.
And that, right there, is the heart of it. See, anyone can stack bricks, right? Or, stack lines of code. But an architect has a philosophy, a vision. They're planning for strength, for efficiency, and for the future. And that's the mindset we're talking about today. Every great building starts with a great plan, no doubt about it. So before we write even a single line of code, we've got to understand the foundational blueprints that are going to guide this whole construction project.
First up, and this one is huge, is don't repeat yourself, or DRY. It's all about hunting down and eliminating redundancy. Because in our world, in code, repeating yourself isn't just wasteful, it's actually dangerous. I mean, just look at the difference here. The novice architect is just creating endless, tedious work for themselves. What happens when the building code changes and you need to add a new kind of handrail? Well, they're digging through hundreds of different plans, and you just know they're going to miss a few. But the professional, they make one tiny change to their master staircase blueprint, and bam, that update is instantly everywhere it needs to be. That's the power of building things to be efficient and reliable from the very beginning. And this is the goal. This is what we're aiming for, a single source of truth. Every piece of logic, every rule, it lives in one and only one place. You know, if you can get this right, you've just eliminated a massive class of bugs and future headaches before they even get a chance to exist. Next up is a classic, one you've probably heard of, KISS, or Keep It Simple, Stupid. Think of this as a constant, friendly reminder against our own temptation to get too clever, to over-engineer things. Because unnecessary complexity, that is the absolute enemy of good design.
Just look at these two bridges. Which one would you rather be in charge of maintaining? The one with all the fancy, complicated features that are a total nightmare to inspect and repair? Or the clean, simple one that just works? In software, the simplest solution that actually gets the job done is almost always the best one. So, we've got our blueprints. It's time to start the actual construction. And this is where we have to make smart choices that aren't just about building fast, but about building for a long-term efficiency and flexibility.
And that brings us to YAGNI, or you aren't going to need it. This principle is your best defense against a trap that, let's be honest, we all fall into. Building features for some hypothetical future that might never actually happen. I absolutely love this analogy. It's just so perfect. Building that helipad adds a ton of cost and complexity for something that will almost definitely never be used. The takeaway here is so simple. Solve today's problems today. Stop building for a what-if future that isn't here yet. Okay, now let's talk about our building materials. This next principle suggests we should think more like we're playing with Legos, snapping together smaller, independent blocks instead of trying to carve our whole building out of one giant, rigid piece of stone. So over on the left, inheritance creates this really rigid chain. If you change something about the glass house, you risk breaking everything connected below it. But on the right, with composition, our house is just made of parts. Want brick walls instead of glass? Cool, just swap out the glass wall component. It's flexible, it's modular, and it's so much easier to change over time. And that right there is the superpower of composition. It lets you upgrade or fix or completely replace individual parts without having to tear down the whole building. For software that needs to evolve, and let's be real, all software needs to evolve, this isn't just a nice to have. It's absolutely essential. So our structure is built. Now we have to think about what's going on inside. The plumbing, the electrical, all the systems. How do all of these complex parts communicate and work together without causing a total mess? Okay, think of this one as the no micromanagers role for your code. Instead of having one central boss that needs to know everybody's business, you empower each part of your system to manage itself. Let's just look at the difference. The Ask Manager is nosy and totally inefficient. They have to know all the internal details about the room just to get something done. But the Tell Manager? So much better.
They just give a command, turn on your lights, and they trust the room to handle the details. It makes the manager's job simpler, and it keeps the room's own business private.
And finally, to tie all this together, we have separation of concerns. This is the big one. This is the architectural rule that says you don't tangle your systems together. You want clear boundaries, distinct responsibilities for every single part of your building. Can you imagine if fixing a leaky pipe under your sink could somehow short-circuit the lights in your living room? That would be an absolute nightmare. A good architect makes sure the plumbing and electrical systems are totally separate. The plumber worries about water, the electrician worries about wires. In our software, this means your user interface logic has no business knowing about your database logic. You keep them separate. This makes the code drastically easier to understand, to test, and to maintain.
So when we put all these pieces together, we really do move beyond just being coders. We become architects, thinking about the big picture and designing software that is truly built to last.
So what does this whole philosophy look like? Well, it means you're using reusable blueprints. That's dry. It means you're designing simple, elegant structures. That's KISS. You're building only what's needed today, not for some imaginary future. That's YAGNI. You're assembling your project from flexible building blocks, not one rigid chunk of concrete. That's composition. And inside, all your systems work together by giving clear commands, tell, don't ask, and by staying in their own lanes, separation of concerns. This is how you build something that lasts.
At the end of the day, every line of code you write contributes to a larger structure. It's your legacy. So the question is, will it be a temporary shack, something destined to fall apart in the first storm? Or will it be an elegant skyscraper that stands the test of time? The choice and the legacy is yours. What kind of architect will you be?